right, our big idea for data continues to be collecting, displaying, and analyzing data helps us to solve problems and to understand the real world. Our concept today is to demonstrate an understanding of constructing graphs and analyzing data. Specifically today we're going to talk about line graphs and series of points graphs. All right, so let's take a look at an example of some data that we need to graph. On December 26, 2004, a massive underwater earthquake rocked the coast of Indonesia's Sumatra Island. It's called a tsunami, or huge ocean waves. This table shows the height of the waves at different distances from the land. So we have the distances from the land in kilometers, 5 up to 30, and we have the height in waves in meters, and all the way from 32 down to 1. Now, to display this data, we need to do a number of things. We need to draw two axes. The horizontal axis, the over, is always the first information in the table. So that's the distance from land, and we're being specific, so it's in kilometers. We also need the height of the waves in meters, and that's the vertical axis. Sometimes, remember, these are called X, and this vertical axis is called Y. X and Y. Let's make that look more Y-ish. There we go. Most important, we need to choose an appropriate scale. So if we looked at our data, we remember that it was from, all right, there we go. Now we can see that data, which will make this helpful. We can see that the distance from land is from 5 to 30. Probably a good idea to count by 5s, which they've done here. So 5, 10, 15, 20, 25, 30. Remember, you're counting the lines, not the spaces. And you have to start at 0. So they counted by 5s on their horizontal axis. The horizontal scale is 1 square represents 5 kilometers, so they've counted by 5s. The height of the waves goes from 1 up to 32. And again, here they've decided to count by 5s, which works perfectly well. So 5, 10, 15, 20, 25, 30, 35, and they've gone up to 40. You could stop at 35 if you wanted to. So then to mark our first point, we would go 5 over and 32 up, which is just a little bit above 30. Okay. For our next point, which is 10 and 20, we would go 10 up and 20 over, right on that square, or that cross point where those two lines intersect. Those two lines are perpendicular if we think back of our grade 5 stuff. 15 and 10 is next, so 15 and 10 right again on where those lines cross perpendicularly. Next we have 20 and 5, again where those lines cross perpendicularly. And then we have 25 and 1, which is going to be just slightly above 0. And again 30 and 1, which is slightly above 0. Now, is this continuous or is this discrete data? Should I be connecting my lines or should I not? Well, the height of the wave, does it jump or does it continuously grow? Will I be able to have a decimal number in there? Could I have a half? It's continuously growing. Or continuously shrinking in this case. And yes, I would have to join my dots together. And there we have our graph. Oh, there is one thing that's missing, the title. The title would be, all right, so our title should be fairly specific, something like Sumatra Island wave heights on December 26, 2004. Something to that effect. All right, and here you see the completed graph from your textbook. As you can see, they mark the points the rest of the way in the data the same way, just like we did. Both distance and height are continuous, so they did use a ruler to join the consecutive pairs of points from left to right. We did that too. Give the graph a title. They gave the graph a title. We gave the graph a title. I think ours was probably better, a little bit more specific. Conclusions that we can make. Since the line segments go down to the right, we know the farther the tsunami is from land, the smaller the waves. So the closer it is to land, the bigger the waves were. We could say our biggest increase of wave height was in the last 5 kilometers, from 10 to 5 kilometers. That would be fairly specific. We could say that both at 25 and 30 kilometers, the distance was the same at 1 kilometer high, and so on. As always, our conclusions can really vary depending on what we're looking at or what points we're looking at on the graph. All right, as we did that graph together, there were some definite things to consider. We talked about the title should be very specific. Each axis needs a title, including the units, the dollars, the degrees Celsius, and so on, and we did include that. The kilometers and the meters were there for us. When we're numbering, remembering to number the lines, not the spaces, remembering to number at regular intervals, 5s, 2s, etc. Remember, we can use the zigzag break if necessary, if there's a large jump in our information. We must start at 0. Remember, this is also called the scale. We cannot jump when numbering unless we've used that break. Numbering intervals or scale does not have to be the same for both X and Y axes. So your bottom axis does not have to have the same numbering as your side axis. There may have to be a legend if you are doing a double bar graph that includes 2 sets of data. So it might be for the color, or it might be for the pattern. And as always, all graphs must be drawn on graph paper, seeking to be understood, making it clear with the data. Otherwise, the clarity is questionable. All right, to practice, we are going to look at a couple of graphs, or you are with your partner. Here we have Levi, who is helping his cousin Kara keep track of the number of chocolate bars she sold and the profit she made. They each drew a graph to show their data. So these are their 2 graphs. Do these 2 graphs first of all, show the same data? How can you tell? Take a moment, press pause. I'll enlarge this here for you. And take a look. Do these 2 graphs show the same data? How can you tell? Press pause and discuss that with your elbow partner. All right, so did you determine that they showed the same data? If so, how did you know? Well, they're both the number of chocolate bars. We have 2 chocolate bars, 2 chocolate bars. Looks like it's a little under $5, and here we do have it at $4, so that point looks like it's about the same data. Here we have 5 chocolate bars at $10. Here we have 5 chocolate bars at $10. It's really looking like it's the same data. And in fact, if we can continue along, here we have 10 chocolate bars at $20 and 10 chocolate bars at $20. One of the things that's missing definitely is the title over here, but that's in both. So I would say yes, they are showing the same data. If that's the case, then why do they look so different? Why does this one look like it's going way up and this one look like it's just going a little bit up? What do you see that's making that difference? Press pause and turn and talk to your elbow partner. What is causing that difference? Well, if you've looked, the one thing that you probably noticed was different between the 2 is the numbering here, the scale. Looks like Levi counted by 5s, whereas Kara counted by 1s. Which one gives you a more exact, a more accurate picture of what's happening? Well, I would say Kara's graph definitely shows the data more clearly. All right, turn and talk to your elbow partner. Between the 2 graphs, what could you improve? What could you improve on Kara's graph? What could you improve on Levi's graph? Press pause and discuss that with your elbow partner now. All right, well, your ideas may be different. And if I haven't thought of your idea, that doesn't mean that it's not a good idea. Obviously, for both of those, I think there should be proper titles. If you look at Levi's graph, there is no title here for this axis, but the same problem occurs here for Kara. So both of them should have that title. There is no title here for Kara's graph. She should have a title. She should specify here number of what that's being sold. And Levi's title, well, it's okay, but it doesn't give us a whole lot of information, so that could probably be changed. Levi's numbering isn't overly effective when we're only going up to 20. So probably counting by ones, twos would be more effective and more clearly show the data. So those are my thoughts. Hopefully you've come up with some of the same. Maybe you've come up with some other good ones as well. All right, now you get to move on to your concept practice, page 265, 266, numbers 1, 2, 3, and 4. Excuse me. You are constructing graphs and analyzing the data. So again, remember all the things we've talked about for constructing graphs, using the lines, making sure to title, using intervals, counting by twos, fives, etc. Plotting your points carefully. And of course your conclusions, if as much as possible, you can make them excellent, detailed, specific conclusions, all the better. Remember, of course, if you have questions along the way, that you do ask. And away you go.